So, we were talking about star clusters, and as we were talking about star clusters, we had already talked about uh, globular clusters. So, what we want to do now is talk about open clusters. And so, the open clusters are going to be a little bit different sort of thing. The open clusters, the open clusters are typically located in the plane of the galaxy. So our galaxy, remember, had kind of a bulge in the middle, and like this side view of the galaxy. And the globular clusters were located in a halo around, but the open clusters are located in the galaxy itself. And so that means you can see them in the sky where you see the galaxy. Our galaxy seen from the inside is kind of a smear across the sky that we call the Milky Way. And so the open clusters are in the Milky Way for the most part, or close to it. And so therefore they're sometimes called galactic clusters in old textbooks. And because they're forming in the plane of the galaxy, which is where all the stars are forming, that's where those spiral arms are, they typically tend to be younger things, and they have more metals in them. The higher metallicity, because other stars have already lived and they've died, and they've enriched the interstellar medium with all those metals, things other than hydrogen and helium. Remember, metal is something other than hydrogen and helium. Two of the closest star clusters to us are the Pleiades and the Hyades, and they're easily visible to the naked eye late winter and through the spring. It's getting kind of late now in the year to see them. They're kind of on the other side of the sun from where we are, so we don't see them right now. But they are things that are typically spring in the evening sky, or in the winter late at night. The Hyades are famous because they're a big V shape in the sky, visible to the naked eye. The star Aldebaran lies right on the edge of it, and I like to point this out that this is in the Taurus, the bull, and the Hyades make up the face of the bull, and Aldebaran, which is a big red supergiant star, makes this big red eye of a really mean bull that's about to charge at you. Okay, all right. Ironically, the school mascot is Toro. Okay. Pleiades. Famous star cluster. You see pictures of the Pleiades because they're very photogenic. They're visible to the naked eye. They look like a little microscopic dipper in the sky. In fact, a lot of students mistake them for the little dipper because it looks so much like a dipper, and it's easier to see than the little dipper. In fact, many of these stars are actually brighter than the stars it's higher in the sky, so the stars look brighter than the dipper stars, which are lost in the sky glow and the light pollution. Now, actually, you probably recognize the Pleiades because the Pleiades are actually used as a corporate symbol. Um, um, just like you've heard of Orion Motion Pictures that uses the constellation Orion as their corporate corporate symbol. There's actually a company that uses this. Now the thing is, this company is a foreign company, and so they use the name of the Pleiades in their language. Okay, the company is from Japan. And in Japan, they don't call this Pleiades. Pleiades are the seven muses. So these are sometimes called the seven sisters. That comes from Greek mythology. In Japan, of course, everything's named in Japanese, and so the Japanese name for this group of stars is Subaru. And so Subaru cars often have a stylized version of the Pleiades as the logo. Beehive Cluster, another really pretty one. And the thing is, Beehive is one that's sometimes visible to the naked eye, just in the same sense that M13 is. In Hercules, for the globular cluster, this is visible, but unlike the Pleiades or the Hyades, which you can see the individual stars with, here with the naked eye, you don't see the individual stars. You just see a fuzzy smudge in the sky because all the light's smeared together. Easily visible in binoculars. It's in the constellation Cancer, which you're not going to see in the summertime because the sun's in the way. But there are others that you can see. So, overview, They're typically young stars, high metal stars. They're gravitationally bound because they formed close enough together. The gravity's holding everything together, but they're loosely held together. Because they're in the plane of the galaxy, there's lots of other things nearby tugging on them, and eventually other things tugging on them pull them apart. We call this process evaporation. And so we would say that the star clusters evaporate over time. And so what happens is that they disrupt, they dissipate. Most stars probably formed in star clusters. So the sun probably formed in a star cluster at one point. And that cluster has since dissipated, and we're no longer part of a star cluster. But there are other stars near the sun that have the same chemical composition, same metallicity, so they formed out of the same cloud of gas and are about the same age. So those may have been siblings to our sun when it was early in a star cluster. So a couple of star clusters I really like that you can see this time of year. So like M13, M7, and M6. Now they're hard to see with the naked eye, though I've seen M7 for the naked eye from really dark sky locations. And they're both pretty easy to find in binoculars, especially M7. And so they're in the constellation Scorpius. And so we've got Scorpius right here, okay, and then this is Sagittarius right there. And so how do you find Scorpius and Sagittarius? Well, once again, you would use the evening sky map, and what you can do is face south, because this is going to be towards the south, and right near the bottom is Scorpius and Sagittarius. And so that lets you find where they are in the sky. The star Antares, big red supergiant star. So to the south, you'll see a kind of a reddish star, reddish orange star, and then that is the star Antares up here, and then that's going to be part of Scorpius. To find M7, what you do is you go down all the way down to the Stinger in Scorpion down here. And so once you get to the Stinger, then what you would do is you would line up with the Stinger and go this way, and typically going in that direction, it's going to be about 5 or 6 distances between those two Stinger stars over. Again, on map 6 of your Mag 5, which you've got posted, down near the bottom, you see Scorpius, and you go over, and that actually marks M7 for you. M7 is also marked on the evening night sky. And so what you can do is you can go out and look and see if you can see that. And if you do, then sketch that. Now, when you use the binocular observing worksheet to submit this for extra credit, what you do is you write down the type of binoculars you have. Don't write the brand name. You can if you want to, but write down 7 by 35 or 10 by 50 or or 10 by 20 or whatever. That tells you the magnification and the aperture. And then if you want to use the other things, I'll post a video actually about how to use those worksheets. But what you would do is basically write it down, sketch what you see in there, and say where you observed from, what city, for example, and latitude and longitude where you observed from. How do you find that? Google it. And then seeing conditions. It goes from 0 to 10. 0 means terrible sky, you can't see anything. 10 means perfect sky. You never get 10s in the Tarrant County area, and if it's 0, that means it's raining or something out, and it'd be silly to go try looking anyway. So don't do that. So what you do is go out and observe it and sketch what you see, and then you can turn that in for extra credit. So you can actually sketch M13 and sketch M7 and M6 if you can find it. M6 is a little bit dimmer and harder to see. But there's a variety of things that you can see, and so this is something that you can do for extra credit visually with just a pair of binoculars. A lot of people don't think about binoculars, but you can use binoculars to actually observe stuff.